Welcome back, viewers. Welcome to another interesting video on stoichiometry. In this video, I'm going to be solving questions now. In our previous video, in the stoichiometry 1, I introduced stoichiometry and I talked about the mole. In the second video, I talked about the molarity and molality and formulas we employ when we want to calculate molarity and molality. In this video now, I'm going to be solving questions on this concept and some other concepts. So let's look at this first question here. This question reads, what is the molarity, RR, what is the molarity of a solution that contains 6.3 grams of NaOH in 300 ml of water? Now, if you notice something, I said in the previous video that examiners make this mistake of giving us the volume of the solution to be the volume of the solvent. And that's why I said I will take the volume in the formula to be the volume in the question. All right? So you have to assume that this volume is the volume of solution. Of course, water is a universal solvent. So it then means that volume given to us here is the volume of solvent. So we'll just take it to be the volume in the question. So solving now. Solution to question 1. Solution. Question 1, we are given the mass. So we are given mass, and the mass is what? 6.3 grams. Take note that this mass is the mass of the solute that was dissolved to make up the solution. Now, what is the volume in the question? The volume in the question is 300 ml. Now, I'm going to solve this question in two ways. I'm going to solve it with normal method, and I'm going to solve it with the shortcut formula. So going by normal method, we said molarity, capital letter M, is equal to number of mole over what? Liters of solution. It then means I need to calculate the number of moles, and now calculate or convert the volume to liters, and then plug it in the formula and get molarity. Doing this, we said in the video in stoichiometry 1 that number of mole is what? Mass over molar mass, which will give us, what is the mass in this case? 6.3 grams. Now, to get the molar mass, molar mass of the substance, which is what? NaOH. Now, NaOH is the substance, NaOH. If you solve everything here, sodium is what? 23 plus, oxygen is 16 plus, hydrogen is what? 1. If you do this successfully, you will get 40 grams per mole. 40 grams per mole. And that is our what? Molar mass. So I'm going to put what there now? 40. So if I divide this now, 40 grams per mole, if I divide this now, I'm going to have, I grab my calculator, so you grab yours, 6.3 divided by 40. We'll have it as number of mole equals 0.1575. So this is number of mole. We have gotten N. Now, liters of solution, I said in the previous video that I gave formulas on how to convert volume. Now, to convert our volume to be in liters now, we will say that the volume will be equals to what now? 300 divided by what? 1000. All right? 0.3 liters. So this is 0.3 liters or 0.3 dmq. So if you put everything now in the formula to get molarity, we have molarity, capital letter M, will be equals to number of mole. Where is it? 0.1575 divide liters of solution. Where is it? By 0.3. If we do this successfully, we will get our answer to be our answer becomes 0.525 molar. So this is our final answer. Now, our final answer, where do we have it in the option? Option C. So option C is the correct answer to the first question. All right? Is the answer to the first question. Now you can pause the video to copy out the solution, how we solved the question using the first method I talked about. Now I want to rub off the board to solve this same question using the shortcut formula I gave in the previous video. So do well to pause this video and copy out the question, copy out the solution. All right. Now, moving on, we need to solve this question using the other method. So I can say alternative method, the shortcut alternative method. So alternatively, we can solve this same question using our formula that I called formula by way of shortcut. So we said that in the shortcut, we have molarity is equals to 1000 times m divided by v times what? W. That's what we said in the previous video. Now, do we have all the parameters here? Yes. What is mass? Mass is 6.3 grams. What is the volume? 300 mil. Now, notice something I said in the previous video, that when this volume is in milliliters or cm cube, that we are going to retain the 1000 in the formula. But if the volume is in liters or dm cube, we will remove the 1000 from the formula. Now, solving with this one now, what about the molecular weight? I said in the previous video that this molecular weight is the molecular weight of the solid, which are calculated in the normal method to be what? 40 grams per mole. That is the molecular weight of the solid, NaOH. Putting everything in the formula now, we have molarity to be equals to what? Molarity, capital letter M, becomes equals to 1000. We will return the 1000 because the volume in the question is in what? Mil. Multiplied by what is the mass in the question? The mass is 6.3. Divide. What is the volume in the question? 300 multiplied by what is the weight? 40. If you grab your calculator and point this now, you will see that molarity, the molarity of this solution is what? 0.525 molar. All right. The same thing we got when we use the normal method. So the shortcut formula is faster and reliable than the normal method, and for such gives us the same answer with the what? With the normal method. So do well to pause the video and copy out the solution. Up next, I want to solve the second question, and this second question introduces a new concept for us here, which is called the mole fraction. Before I move on to solve question 2, I will need to explain to you what we mean by mole fraction, and I'll give illustration here. So do well to pause the video and copy out the solution. So this is how this question can be solved using the shortcut method. Now moving on now, we have a concept called mole fraction. Mole fraction in chemistry, we present it as letter X, so that if I have two substances being combined to make up a solution, and I'm asked to calculate the mole fraction of any of them, let's assume we have substance A and substance B, and in the question we are given the mole of A to be 0.3 and the mole of B to be 0.1. If we are asked to find the mole fraction of A in the question from this parameter, so I'm going to write it as XA, which is the mole fraction of the first one. It is going to be what? The mole of the A, which is 0.3, divided by total mole, which will be what? 0.3 plus 0.1. So we point that we plug this in our calculator and get the final answer. So this is how to calculate mole fraction. What if we are asked to calculate the mole fraction of B? It will be XB will be equals to, what is the mole of B? 0.1 by the total mole, 0.1 plus 0.3. So this is how we go about solving questions on mole fraction. But look at this question here. If you look at this question very well, you see that the question says a solution of glucose is 25% weight by weight. So this in here means W/W, all right, which stands for 25% weight by weight of glucose. Now, in this illustration I gave here, and I just gave the number of moles straight, so we can just solve directly and get our answer. But in solving questions like this, we need to understand the interpretation of the question. This question says, because we actually need the number of moles of each of the substances that are involved, we are asked that we should calculate the mole fraction of what? Glucose. All right. Now we are given 25% weight by weight. The first question we ask ourselves, what is the interpretation of this statement? This statement will mean, now because it is for glucose, all right, this is for glucose, it will mean 25 grams of glucose dissolved in. Now total percentage is 100. If you subtract 25 from 100, what will be left? 75. So it is going to be 75 grams of what now? Water. All right. So maybe I'll put it up here. So see what I mean. See what I mean now. It then means in effect that when we are given 25%, it becomes 20. That 25% we call it gram of the solute. Then to get the gram of the solvent, we subtract that percentage from 100, which is total. All right. Now, what if the question says 2% weight by weight of glucose? What this would have been is 2 grams of glucose dissolved in what? Dissolved in, subtract this 2 down from 100. You have what? 98 grams of water. So this question needs interpretation before we go ahead to solve it. All right. So now that we have successfully given the interpretation of this question, up next is to solve for the mole fraction. And of course, in the first video on the mole, I gave formulas for calculating mole. And we said in that video that the mole is calculated using mass over molar mass. So directly we can say number of mole is equals to what? Mass over molar mass. So for glucose now, number of mole of glucose will be what? Mass of glucose divided by what? Molar mass of glucose. This will give us mass of glucose in the question. From our interpretation, we said 25 grams divided by the molar mass of glucose. Of course, we are given in this question, which they say equals to 180. Of course, glucose is C6H12O6. If you calculate everything here successfully, you are going to have 180 grams per what? Per mole. So doing that, this becomes 25 by what? 180. So if we get that, number of mole of glucose becomes 0.111111 like that. Let's confirm that with calculator. All right. So let's check. Let's confirm that. So we have it as 25 divided by 180. Okay, 25 by 180. So we have it as 0.13888. So this is our number of mole of glucose. Now, what about the number of mole of water? Number of mole of water will be equals to mass of water divided by molar mass of what? Water. This will give us, what is the mass of water? From our interpretation, we say it is going to be what? 75 grams. Divide. What is the molar mass of water? Of course, water is written as what? H2O. If you solve everything here, you are supposed to get 18 grams per mole. So this becomes 75 by 18, which will give us 75 by 18. So we'll have it as 4.1666. All right. Now, all right. Now we have gotten the mole of water and the mole of glucose. How do we now get the mole fraction of what? Glucose. It will now mean mole fraction of glucose will be equals to mole of glucose, number of mole of glucose, over number of mole of glucose plus number of mole of what? Water. So doing this successfully, we say mole fraction of glucose is equals to, what's the mole of glucose? See it here, 0.13888 divide mole of glucose 0.13888 plus what's mole of water? 4.1666. So we'll do that. So we'll sum this one first. So that mole fraction of glucose will be equals to plus 4.1. So we have it to be 0.13888 divide 4.30. So this is 4.3054. So if we divide these two, so we are having it as okay, this is our answer. So mole fraction, look, let me put the answer here. The answer becomes 0.03445. All right, where do we have that? Which option do we have that? 0.0344. Where is option A? It can't be this. It's not this. 0.3. Okay. 0.05, 0.04. All right. So this should be it. So our option is what? Option D. All right. So you can do well to use your own calculator to confirm the final answer. But this is the method we use when we want to solve questions on mole fraction. Do well to pause the video and copy out the solution to the question and the solution. Now, I want to solve one more example on molarity so that in the next video, we will be talking about molarity and normality, which we will solve questions on them as well. Now, what do we do now? I'm going to put up a question here, so I'm going to remove this one now. So I'm going to drop a question here now, which I will solve as the last question in this video. Now, what is this question? So we can take it to be question 3 now. So calculate the molarity of a solution made by dissolving 11.5 gram of solid NaOH in, all right, 1.5 liters of solution. So let's look at this question. That will be all for this video. So in the next video, we'll look at molarity and normality. That's examples.